So now we're going to look at a new term we're going to use here called an equivalence class. So the definition, we're going to say for an equivalence relation R defined on a set A, and you need an element for an element out of your set, so A and A. The set, the way we denote it is with brackets, and it's the set of all X and A where X is related to A, consisting of all elements in A related to this element A is called an equivalence class. So let's look at an example here. And to do this, we're going to revisit an earlier example. So I'll say, recall that we previously showed the relation R defined on Z by A relates to B if 2 divides A minus B is an equivalence relation. So in an earlier video we showed that this relation was reflexive, symmetric, and transitive, which means it is an equivalence relation. And so I want you to write some elements of the two equivalence classes 1 and 2. So in order to do this, you're going to have to think, let's start with the equivalence class 1. What are some elements that are going to be related to 1? So let's look back at our relation here and look back at our definition of an equivalence class. So I need to find all the elements X. I need to find some elements X such that X is related to 1. What does it mean for X to be related to 1? It means 2 divides X minus 1. Well, if X is 3, then let's even start smaller. If X is 1, then this will say 2 divides 0, which is true. If X is 3, then this will say 2 divides 2, which is true. If X equals 5, 2 divides 4, which is true. So some of the elements in the equivalence class for 1 would be 1, 3, 5. And this is actually an infinite equivalence relation, so there's numbers smaller than 1 as well. But there I found 3 elements of the equivalence class for 1. Now remember that because this is an equivalence relation, we know that 1 relates to itself. So 1 is in my set, my equivalence class, but I found two other elements, 3 and 5. Now let's look at the equivalence class for 2. Actually, I'm going to change this. Let's find the equivalence class of 0 here. That's what I really meant. So 0 so I need to find all the elements that are related to 0, right? That means 2 divides x minus 0, or just 2 divides x. Well, what are some numbers that 2 divides? Well, 2 divides 0, 2, 4, 6, and so forth. And you do have negative numbers. I didn't include any here, but I could have also written down -2 as well. So here are some elements of the equivalence class of 0. Again, 0 will be in this set because this is an equivalence relation. It's reflexive, so 0 has to relate to 0. But then I get these other elements. But if you look at these equivalence classes, you can notice something is going on here. So if I look at 0, all of these numbers that I've written down are even. So you can describe the equivalence class of 0 as containing even numbers. And then up here, 1, 3, 5, this equivalence class corresponds to odd numbers. So here, remember that every integer is either even or odd. So in this case, I only get these 2 distinct equivalence classes. I get this equivalence class and then this equivalence class.